Hello everyone, a Leetcode a day. Today our question is minimum domino rotations for equal row. This is a very popular Google interview question. As we can see, Google has asked this question a lot of times over the past half year. So let's directly look into the question. Essentially, this question is about two arrays, but in the settings of dominoes. So in a row of dominoes, AI and BI represent the top and bottom half of the ice domino. And we try to rotate the ice domino so that AI and BI swap their values. And then we try to make all the values in A are the same or all the values in B are the same. And then we return the minimum number of rotations. So let's look at the two examples here. For example, in the first one, A is 2, 1, 2, 4, 2, 2, and B is 5, 2, 6, 2, 3, 2. So if we rotate let's look at the array A. So if we rotate this one and this one, then that means the second element and the fourth element in A will rotate or swap the value with the element in B, which is exactly 2. So in that case, if we rotate twice, that will make all the elements in A equal to 2, right? So that's why the output is 2. And for the second example, A is 3, 5, 1, 2, 3, and B is 3, 6, 3, 3, 4. So for the first element, it's the same. So we both A and B are 3, so we don't have to make any rotations. But for 5 and 6, right, no matter how we rotate them, it cannot equal to 3. That's why we output -1. That means it cannot be done, right? So actually, let's think about this question. So actually, after we look at the first element of A and B, the problem is already fixed, right? So let's say for this example, A0 is 2 and B0 is 5. So the goal is one of the following cases. Either we do some rotations to make all the elements in A equal to 2 or 5. Or we can also try to make all the elements in B equal to 2 or 5, right? So that's a basic idea. And if we cannot never make it, then we return -1. With this idea, let's look into the code. This is actually the implementation is very straightforward for this question. So the input for our function minimum domino rotation is two arrays A and B, which represent the top and bottom halves of the ice domino. And then because we want to return the minimum counter, right? The number of rotations. So we make 4 counters to record the number of rotations and then try to find the minimum. As we just discussed, we have actually 4 cases, right? So the first case, we want to make all the elements in A equal to A0. And the second case is make all the element in A equal to B0. It's the same for make all the element in B equal to B0, or make all elements in B equal to A0. That's why we have 4 counters here. So let's look at one of the cases, because actually the case is very similar. So if we want to make all the elements in A equal to A0, so we iterate through all the elements in A, and if AI is not A0, and at the same time BI is equal to A0, right? In that case, if we rotate the i's element, then all the elements before I should be all equal to A0. And if AI is not A0, and also BI is also not A0, in that case, we cannot make this case happen, right? Because that means no matter we rotate or not rotate the ith element in I, we cannot make all the elements in A equal to A0. So in that case, we will break and also make the corresponding counter to be a infinite number. So you have to be careful. We cannot directly return -1 here, right? Because we cannot make all the elements in A equal to A0. Doesn't mean we cannot do others, right? So maybe you cannot do this, but maybe you can do this. It's the same. But you can make like all the elements in A equal to B0. That's why we first, if we encounter some cases like this, we make the counter to be infinite. And it's the same for if we want to make all the elements in A equal to B0, right? So after we calculate those 4 counters, because those 4 counter will include all the cases possible. So we just return the minimum of those 4 if it's not infinite, right? If the minimum of the 4 is infinite, that means all of them are infinite, and that means it's impossible. So in that case, we will return -1. For the time complexity, because we have like 4 parallel 4s here, and so the time complexity is basically big O. It's a linear time, right? For the space complexity, it's O1 because we only have 4 counters here. So if we look at this solution, right, it's very tedious, and it's like we have 4 cases here, and actually the format is very similar for all those 4 cases, right? And then we can think of this is a bad coding style, and we can think of, can we make it like more concise? Of course, yes, right? So if we can see a lot of redundancy in our code, basically what we do is we try to make a function, right, to abstract the format. So let's then we with that idea, we define a function called x2y. Basically, it's with the previous format, we can see if we want to make all the elements in x equal to a0, y0, then we can directly use this function to calculate the corresponding minimum value. And all the other things are the same, right? So in that case, the time complexity is still linear, and the space complexity is constant. That's it for this question. If you think this video helps, please like and subscribe my channel. Thanks for watching.